Subnetting, a primer. So if I pull this up and I'm looking at an IP config, this is what comes back. And if we look at this, there's a lot going on here. So first, I see connection-specific DNS suffix, which we can talk about later. IPv6, and we'll get into the difference between IPv4 and IPv6, but today we're mainly going to be focusing on IPv4, which is what most people are commonly using. So I look here and I see my IPv4 address, 192.168.86.141, but I also see the subnet mask, and this is 255.255.255.0, and the default gateway, which is going to be my router, or at least the entrance point of my router, the ingress port. But for most consumers, that would just be your router. But let's really look at the IP address and subnet mask, because this is going to be really important when we talk about subnetting. So the IP address is my unique address. My IPv4 address is the unique address, and that's got to be unique because that's what packets are going to be sent to. The subnet mask, though, defines the boundaries of my network. Okay, so we're going to start real simplistic and then we'll get a little bit deeper. So this says 255. If there's 255, by the way, is the highest number you can have, and we're going to get into binary to decimal conversion in a second to really help understand this, because we have to be able to understand this when we get to subnetting itself. But let's start with 255. 255 is the highest number you can have in an IPv4 address. And there's a reason for that, and that's because it's 8 bits. Okay, and 8 bits, the highest number you can have is 255, and I'll show you that in a bit. But if the number is 255 like it is here, okay, and you line up the subnet directly to the IPv4 address, if it's 255, and this does not work if it's not 255, okay, but if it's 255 in the subnet, then the IP address above it will be part of the network address, okay, and I'll explain that here in a second. So again, that's 255, and again, that's 255, okay? Notice this last one's 0. So what this means is that this is a network bit, and this, well, part of the network address as it is, and this is part of the network address, okay? So 192.168.86 is the network address, meaning this can't change. So this address, 192.168.86.0, goes all the way to 192.168.86.255. That is the complete range of this network, okay? So these first 3 octets, and we'll get into that in a second, these first 3 octets, 192 being the first octet, 168 being the second octet, and 86 being the third octet, are part of the network address. This cannot change, okay? So 1 octet, 2 octet, 3 octet, 1 octet, 2 octet, 3 octet. These cannot change. If they do change, it's part of another network, okay? And that's super important. And why is that part of another network? Because of this subnet mask, okay? Remember, I said if it's 255, then that makes the IP portion above it part of the network address. So then that means this last piece here, okay, we'll do this in green, this last piece here, okay, that's going to be the host address, okay? What does that mean? This part here to this part here. That's what can change, okay? These are the numbers that can change. And just kind of having a preliminary understanding of this will help a lot, okay? So the network addresses can't change, the host number can change. And of course, the network can change. I mean, we can change the 86 here to another number, but it would mean it's a different network, and the devices would not be able to communicate to it. Okay. So with kind of that as a basic understanding, let's do an overview real quick of IPv4 versus IPv6. So we look at IPv4, okay? IPv4 has, there we go. IPv4 is 2 to the 32nd power, okay? And 2 to the 32nd power is approximately 4.3 billion. And you can actually see the number there exactly. So 4,294,967,296. Okay, that's the actual number. So when the internet was first created, and we started moving along, first originally called ARPANET, and then as it kind of kept going, and we hit IP version 4. Literally, the engineers and designers looked and said, look, we got 4.3 billion unique addresses. Okay, and that's what's important, is that this makes a combination of approximately 4.3 billion uniques. And every computer, every device must have an IP address. So they have to be unique. Otherwise, the entire thing breaks down. Okay, so this came along and they're like, oh, look, we've got IPv4. It's 2 to the 32nd power, 4.3 billion uniques. We're good. Unfortunately, the World Wide Web then happened in the 90s. When the World Wide Web happened and everyone started going on, this quickly became a problem, okay, which is going to get to our main focus today of subnetting. And it's really a Band-Aid solution in order to be able to try to preserve some of our leftover numbers. Because as you can imagine, we have over, 7 billion people in the world, plus multiple devices each. We've long expired this. So now we're using Band-Aid solutions in order to be able to continue the internet functioning. Luckily, well over 15 years ago, IPv6 was created. And this is 2 to the 128th power. And there's your number. That reads as approximately 340 undecillion. This is not just a little bit larger. This is exponentially larger. We never want to say never, but we're probably never going to run out of IPv6 addresses, at least not for the foreseeable future. This is an absolutely giant number because, again, this is how many uniques. Now, if you're like, well, yay, we solved the problem, we're good. The problem is IPv6 and IPv4 are not backwards compatible, okay? Meaning it's two separate internets. So what's happening a lot right now is people running IPv4 because that's the original, what everybody's using, plus you have servers, plus your home computer could also be running IPv6, but it's literally running at the same time. It's an either-or situation. Sometimes we'll stick an IPv6 inside an IPv4 frame or packet, but that's not... It's again a Band-Aid solution. Ideally, we should be running pure IPv6 everywhere, but it would require the entire world to change because it's not backwards compatible. It is two separate internets. And therein lies the major problem, okay? So before we get into subnetting and what that means, we have to do a little binary to decimal conversion, because at the end of the day, when we look at, and let's go to CIDR, okay? When we look at an IPv4 address, it looks something like this, okay? 192.168.0.1/24. And we'll explain that here in a second. But what does this mean, okay? This is that IP address in decimal notation. What we like, what we've learned, okay? We work with a base 10, okay? What does that mean? A base 10, and this is what we learned in elementary school. So a base 10 system, okay, means we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, okay? And that's what we've learned growing up. We have the ones column, we have the tens column, etc. However, computers don't work on the decimal system. They work on the base 2 system, and that has 0 and 1. And the reason why we do binary in computers, because this goes back to early circuits, basically true and false logic or on and off, okay? Which is why, fun fact, if you look at the back of your power supply, you will have a 0 and a 1, because a 0 is off and a 1 is on. And this has to do with basic circuitry. So even though we write this in decimal, that's really for human readable form. It's really about binary, okay? And so this is why each one of these, 192, okay, is 1 octet. So this is going to be octet number 1, okay? Why is it called an octet? Because an octet means 8. And that means that's 8 binary bits, okay? And I'm going to show you in a sec what that means, like as far as the highest number, okay? So then this one right here is going to be octet number 2. And this right here is going to be octet number 3, which leaves this one as octet number 4. Okay, and it's important to know that because we'll often say like the third octet or the first octet or the second octet. And again, we call them octets because it's really binary, but we refer to the decimal form as octets as well. Okay, so now let's look at the /24. What in the world does this mean? So this came with the way IPv4 was originally done. So when we look at this, and this is from Aaron, so this is the non-profit form of IANA. This is for North America. And IANA distributes all these IP addresses around the world. Okay, but then there's regional authorities, and for North America, that's ARIN, and there's various ones for different continental splits. But when we first did this, we had the subnet, because remember, the subnet defines your network, and that's important. So when we first did this, we had what's called a /8, okay? And that was what we call the A, okay? And the A allowed for 16,777,216 IPs. Okay, that's how many unique IPs that network could have. So this was an absolutely huge number. Then we also had /16. That was considered a class B. That had 65,536. Then we also had the traditional class C, okay? And class C is what most consumers have. And that is 256 uniques. Okay, that's how many IP addresses you can have in your network. Okay, so that's a /24. And this is fine, but the problem is as we have moved on into more complex networks and frankly running out of networks, we've had to break what's called class full addressing. And you can see we have up here, it literally says unused since 1993. Okay, so class full we've kind of broken down and said, okay, well, technically we can use any combination thereof. Okay, and that's what this, and again, if you're like still a little confused on this, I just want you to see that that's what that /24 means. Okay, so that /24 right here, this is related to what we call CIDR or classless addressing. So that's what we're going to learn, and that's what we're going to go through and kind of figure out what that means. So in a nutshell, /24 means 24 network bits. Okay, so let's look over and now let's actually start doing some binary to decimal conversion. Okay, so when you look at this, we can kind of see 8 bits is 1 octet. Okay, so when we have something like 255.255.255.0, okay, we say that's equal to a /24. Well, why is that? Because that means there's 24 network bits. Well, what does that mean? Okay, so let's look. So I'm going to take this 255, okay, and I'm going to break that down into its binary equivalent. And that is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is 8 ones. Now, each octet we said, this is an octet, okay? This is octet 1. That's octet 1. Each octet is 8 bits. Okay, so in order to understand this, we actually have to convert, again, binary, decimal to binary. So if there's 8 bits, we have 2 to the 0 power, 2 to the 1 power, 2 to the 2nd power, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. And if I count that, that's 8 bits, right? 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so if we do that and we convert each one of these exponents, 2 to the 0 power is 1. Okay, 2 to the 2nd power, or 2 to the 1st power, excuse me, is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. And 2 to the 7th is 128. This chart is extremely important. Okay, so if I want to convert binary to decimal or decimal to binary, it's all about this chart. So for those of you taking certification tests or anything else, one of the first things you want to do on the laminated piece of paper is write out this chart. And it doesn't matter. You do not have to write this part. This is just really an explanation. The power of this chart is this right here. Okay, and it's easy to do. You can quickly just jot it down. So we go 128 and then have it 64, 32, 16, 8, 4, 2, 1. Okay? And you draw a line and go boom, 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 boom. Okay? Just remember, you start at 128 and keep having it till you get to 1, and then you're done. So I want to now prove this 255 thing. Okay? So we're going to look at this 255, and we're going to see why is 8 ones 255. So once you make this chart, okay, you're going to plug the ones into the chart. So quite literally, I'm going to plug a 1 in here and 1 here. 1, 2, 3, 4, 5, 6, 7, 8. Because again, 8 bits is for 1 octet. Okay, so I plugged all these in. Cool. Now what? Okay, here's what you do. Anything that has a 1, you add the column above it together. So let's start at the left. Always start at the left with this table. It's very important. So the first one I see is 128. Does that have a 1? Yes, it does. So I'm going to add that to the next column if that has a 1, which it does. So 128 plus 64, let's look to the right, plus 32, plus 16, plus 8, plus 4, plus 2, plus 1. Okay? And let's see what happens. So we'll take our calculator here, and we're going to go 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and we have 255. Okay, so there is your first experiment into binary and decimal conversion. Okay, so we converted binary to decimal. Okay, and we can go either way around that, and I'll show that. Okay, so that's what that means. So how many unique numbers are there in 1 octet? It might be like, well, 255. Actually, in 1 octet, there is 256. And a lot of people go, that doesn't make sense. All ones would be 255. Yes, but don't forget to include the zeros. Okay, so in each octet, the number range of any octet can go from 0 to 255, which makes a combination of 256 unique IPs. Now, when we get into subnetting and things like this, understand that technically this gets a little more complicated because you can't use the first one and you can't use the last one. Okay, those are not usable. The first IP address in a network is going to be like the name of the network. Okay, so in a network like 192.168.86.0, okay, it's going to matter what the subnet is because that's going to define the range. But in this particular one, if we say it's a /24, okay, like what we see down here, then that's going to be 192.168.86.0 all the way to 192.168.86.255. Okay, that's the full range of IPs for that network. However, we cannot use .0, the first one, nor can we use .255. .255, the last one. Reason being is .0 is considered like the name of the network. Okay, so you can't use that. It's like the identifier. Where .255, the last one, is the broadcast. And you can't use the broadcast because special features in a network use that. For example, ARP. Okay, so if you were to be at .255, if you were to be the last in your network, then everything you sent would be broadcast out to everyone all the time because it's a broadcast address. It's a reserved number. So the first one and the last one you could never use. So what's usable in this one? What's usable in 192.168.86.0/24 network? Usable is .1 to .254. Okay, that's what's usable. That's what we can assign to device. You might be like, well, .1, that's usually my router. Still a device. Okay, it's still usable. Technically, we can assign anything to the router. Okay, so now let's see if we can go through and do some more binary to decimal conversion to see if this makes sense. So I'm going to erase this all, and then we're going to start with that. Okay, we're all erased, and so now we're going to go decimal to binary conversion. So I'm going to teach you decimal to binary conversion, and then we'll go binary to decimal. So we'll kind of go back and forth in each one, okay? So, and the reason we'll start with decimal to binary is I think it's the hardest to understand, okay? So we're going to start. Now, as I just explained, for each octet, we can have 0 to 255. Okay, so 255 is the largest number we can have. If you ever see anything more than that, then that's a Hollywood film or something. An IP version 4, 255 is the largest number you'll ever see in an IP address. It has to be, because we just proved that. So we're going to come up with a random number between 0 and 255. Okay, so let's go for, I don't know, 143. Okay, so we're going to take the number 143 and we're going to convert that to binary. Okay, so to take 143 and convert that to binary, I'm going to have my table. Okay, so remember, this is what I care about. This part up here, this is just, this part up here, this is just for reference. Okay, you don't need to write that out. So honestly, we can just kind of take that. When you normally write this out, don't worry about this. We'll just kind of, okay. I mean, it's important in case you forget, but what we really care about is the 128, 64, 32, 16, 8, 4, 2, 1 column. Okay. So I'm going to take this and I'm going to look at my number. Okay. This is what we're going to try to make 143 in binary. So I'm going to start on the first column to the left, and that's important. You've got to start in the first column to the left, which is going to be the 128 column. Okay. And I'm going to look at the number 143 and 128. And I'm going to ask myself, is 143 greater than or equal to 128? Okay. I can also inverse this and say, is 128 less than or equal to 143? Either way is going to give me the exact same results. Okay. So is 143 greater than or equal to 128? Yes, it is. So I put a 1. Okay. Now here's the important part. Now I've got to take the 128 and I've got to minus that, okay, 128, and I've got to minus that from 143, okay? If you're allowed to use a calculator, use this. This is basic subtraction, okay? But most certification tests will not allow you to use a calculator. So know that. So you might need to do this by hand if you're not very good with subtraction. If you can do this in your head, great, but do not mess up on the subtraction. If you're even one number off, it's going to be completely messed up. Okay, so make sure you can do this. And if you're still you can use your hands or anything else. Okay, again, for certification, just make sure you get this through. So I'm looking at this. Let's go old school in case some of you need to. So 143 minus 128. Well, 3 can't minus from 8, so I'm going to borrow from here. Make that a 3, make that 13, okay? That would be 5. And then I have 3 minus 2, that's 15. Okay, this is now the number that I'm looking at, and that's what's important. So you take your column and minus from your starting number. Okay, once now I'm looking at the new number, 15. Okay, so is 15, the number 15, is that greater than or equal to 64? No. So you put a 0. Now let's look at the next one. Is 15 greater than or equal to 32? No. Now let's look at 16. Is 15 greater than or equal to 16? No. Is 15 greater than or equal to 8? Yes. So I put a 1. Now take this column, 8, and minus that from the number that you just had. Okay? So 15 minus 8 is going to be 7, right? 7 plus 8 is 15. So now this is the new number I'm looking at. Okay? Is 7 greater than or equal to 4? Yes. So then go here and minus 4. 5, 6, 7, that's 3. That is now the number that I'm looking at. Okay? Is 3 greater than or equal to 2? Yes. Put a 1. Okay? And then I'm going to take that column, minus it from that result. Now I have 1 left over. Is 1 greater than or equal to 1? Yes. Okay? And then I take 1, minus 1, and of course, that's 0. So 143 is equal to 1, 0, 0, 0, 1, 1, 1, 1. And that's how you do decimal to binary conversion. Okay? And we can check this a couple different ways. Okay? Let's check it manually. Because I said anything with a 1 I can add together, right? So let's look at it. So let's go 128, that has a 1, plus what's the next column that has a 1? 8, plus 4, plus 2, plus 1. 143. And if you have a calculator, this is the Windows calculator, you can actually even go to Programmer here, and I can type the decimal of 143, and look at the binary. 1, 0, 0, 0, 1, 1, 1, 1. Okay? So that's how you do that. Pretty easy. Just remember, this calculator might be like, well, then why do I even need to do this? Because you can't use a calculator on a certification test. And honestly, beyond the certification test, you should learn how to do this anyways. Because yes, most people in the industry use what we call subnetting calculators. So they're not doing manual decimal to binary conversion, yet if you know how to do it and you've done it enough times, then it's good because you could be using a subnetting calculator, mistype something, and you would never recognize it. So I actually strongly believe this is something you should be able to do. Okay, so that is decimal to binary. Let's do one more decimal to binary, and then we'll go reverse, and we'll go binary to decimal, just to make sure you can go both directions, because it's super important. Okay, so let's pause, and I'm going to erase the screen. Okay, screen is erased. And so now we're going to use another number. So again, we'll start with any number, and it has to be between 0 and 255. Okay, so let's go for, I don't know, let's go for 208. Okay, so we're going to do 208. Actually, you know what? I want to do a smaller number. Because there's something I want to point out on that. So let's actually do the number 37. Okay, so we're going to go really small this time just because I want you to see the front zeros, and that's important. Okay, so starting off, this is the number that we're going to put into binary. So I'm going to look at that. So is 37 greater than or equal to 128? Again, first column here. Okay, so is it greater than or equal? No. Okay, is 37 greater than or equal to 64? No. Is 37 greater than or equal to 32? Yes. Okay, so I'm going to take 32, because that's my column that I put a 1, and we're going to minus this. Okay, so we've got 5 left over. So is 5, now remember, we're looking at the result from the subtraction of the column. So that's the new thing we're looking at. So is 5 greater than or equal to 16? No. Is 5 greater than or equal to 8? No. Is 5 greater than or equal to 4? Yes. So we're going to now take our column of 4, minus it from 5. We have 1 left over. That's now the number I'm looking at. Okay. Is 1 greater than or equal to 2? No. Is 1 greater than or equal to 1? Yes. Okay. And again, we don't have to do this last one, but just to show you, then it minuses 0. So 37 is equal to 0, 0, 1, 0, 0, 1, 0, 1. Okay? And that is the answer. Now, the reason I wanted a lower number is I just want to point out, sometimes we'll do something like, hey, 2, well, that's the same as 0, 2. That's true. In binary, though, if we're talking about an 8-bit number, an 8-bit binary number, don't exclude the first zeros, okay? Write it out. So 37 is equal to 0, 0, 1, 0, 0, 1, 0, 1, okay? And that is what it's equal to. And once again, I can open up my calculator, okay? And I can type, and if we want to check it just in kind of the full cheating mode, I can go 37, and you can see right here, 0010, 0101. Now notice they put a space here for ease of use, but ideally you wouldn't do that. I mean, you can do that. That just means it's 2 4-bit pieces. Together it makes 8 bits, so that's fine. But I can also check it the standard way, which is what I would suggest, because you're going to have to do this by hand. So just add up the columns that have 1s. And I'm getting used to what we're about to do. So 32 has the first one. So 32 plus 4 plus 1 is 37. Okay, so nice and easy. Now let's do the opposite, and let's convert binary to decimal. And this is going to be super simple. So as long as you can do decimal to binary, that's the hardest part. And that's what you're going to be doing most of the time, but sometimes you're going to have to go the opposite way. Okay, so let's erase everything. Here we go. So we're going to take the binary, and if you're going to work binary here, so the easiest way to do this is we're just going to go, okay, so start with, we're going to do 1 here, 0, 1, 1, 1, 0, 0, 0. Okay, so we can easily do that. And if we do that, okay, pen was getting a little crazy. So here we go. So I just randomly came up with a binary, but obviously you would have a binary number already in front of you. So all you do is you just put it in the same chart we've been using. Okay, and this becomes real easy because now, once you put it in the chart, we're just going to add together the columns that have 1. So 1, 0, 1, 1, 1, 0, 0, 0. 1, 0, 1, 1, 1, 0, 0, 0. What does that equal? So 1, 0, 1, 1, 1, 0, 0, 0 equals 2. Well, let's take 128, and we're going to add the next one that has a 1. That's 32. Okay, so it's 8, 9, 10, carry 6, 1, 160. And now we have 16, so let's add 16. There we go, 6, 7, 176. Okay, and now it looks like we have an 8. So let's add an 8. Okay, and so that's going to be 14, carry 8, 184. And again, do math however you need to. A lot of you are going to be a lot faster than this. Great. I'm just making sure that you can do this slowly and by hand, okay, because that's important. And then that's the last one that we have column in, right? So 184 looks like it's the answer. 184. Okay, that's it. And we can double check with our calculator. And again, that's going to be 128 plus 32 plus 16 plus 8. 184. Okay, and again, this is simple math, but don't mess up on basic addition or subtraction. That's all you're doing, but if you mess up, it changes everything again. And again, Notice in binary on the calculator, and you should be testing yourself on this to make sure that you know how to do this. So use the calculator to test yourself to make sure that some of your fundamental math concepts or a fundamental part of this you're not messing up. So you're going to go 1, 0, 1, 2, 3, 1, 2, 3. And there we go. Decimal's 184. Okay, so you can always make sure that you're good on all of that. Okay, so now that we understand how to move decimal to binary and binary to decimal, now we need to start actually talking about, so what is the subnetting thing? So why learn how to subnet? Subnetting is taking one network and dividing it into smaller networks, okay? And that's a really important concept. It's dividing it into smaller networks. Okay, so we're going to start out here with a network of 192.168.1.0/24. And if we remember, again, /24 represents how many network bits there are in the subnet. And you always start from left to right, okay? So, for example, if I'm looking at a /24, okay, that's going to, and do this because how many bits are there in IPv4? There's 32 bits, and that's super important because remember, IPv4 is 2 to the 32nd power, okay? And that's an important number, remember, 32. So if you see your slash, then basically start writing out ones and then just go from the left to right, okay? And you've got to, so the number, this number is how many ones I have, okay? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Let's write all of them. Well, I'll continue. Okay, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've hit all the ones. Now continue counting until you reach 32, but now go to zeros, okay, because these are host bits. So now I'm going to start continuing. So we have 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, and this is what you should do. When you first see this, this is kind of an important visual for you to understand. Okay, so this is the subnet written out. Now, the only thing I need to do here is I want to make sure that I put in my decimals. Okay, so that's every 8. So let's go back to the beginning and we're going to count every 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the first octet. 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's the second octet. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And we should have 8 zeros left. 1, 2, 3, 4, 5, 6, 7, 8. And we do, because 32 minus 24 is going to be 8. All this is extremely important. That's why I'm having you write it out to visualize this first, okay? So a /24 looks like this in binary. Remember, the ones are network bits, okay? So anything that you see here, the ones are network bits. So this is network bits, this is network bits, this is network bits. However, that green, these are host bits. Host bits are what can be assigned to devices. Okay, so /24 and translated this, but we know this already. That's going to be translated 8 ones is 255, which we've already shown. Another one, 255. Another one, 255. Okay, and 0, of course, is 0. Okay, so easy. But we're going to have different forms of this. If it's not a /24, then you need to write it out just like this. So let's say it's a /23, okay? So we're gonna change this for a sec, just for fun, to /23, okay? So now I've gotta take this one here, and that becomes a 0, okay? And that makes sense. If I count this now, I'm gonna have 23 ones, and I'm gonna have 9 zeros. That changes things a lot. And again, I'll come back to that, okay? So what would this address be? This would no longer be a 255, okay? So it'd be 255.255. What? Well, that's a 0 right there. So what do? Let's pop it in here. Okay, so we're going to go 1, 2, 3, 4, 5, 6, 7. And then the last one here is going to be a 0. Okay, so if we add all these together, or, and again, not to confuse you, but being it's just a 1 here, okay, well, we know it's 255. So being I just have a 0 in the ones column, I can also say, well, it's 255 minus 1, so that would be 254. Okay. But if you add it together, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, we should come up with 254. Okay. Again, don't believe me? Try it. You need to practice this as many times as possible to make sure that you see it. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2. There we go, 254. Okay. If you're not, if some of you are very comfortable with math, and so this might seem elementary, and that's fine. Okay. But for those who aren't, hopefully this will help. So a /23 network would be the equivalent if I was programming it as 255.255.255, excuse me, 255.255.254.0. Okay, that would be a /23 network. Okay, so what does all this mean? Well, once we understand this network and host bit things, now we can start looking at subnetting. Okay, so we're going to erase everything, and there we go. So let's erase it all and start with this concept of a /224. So what does it mean, a /24? Well, we already said that means early on that you can use from .0 to .255. Okay, and the first ones here are going to be network bits. But we're now concerned about these host bits. Okay, so that's a network bit, that's a network, that's network. These can't change. So the only thing that can change here is this last one, because these are host bits. So if I take 32 minus 24, okay, because there's 32 bits total, so we're going to decide how many host bits we have. So how many host bits is going to equal 8, okay, because 32 minus 24 is 8, and there's 8 zeros, correct? So 8's really important because this is going to tell us how many IPs we have, okay? So 2 to the number of host bits, okay, is how many IPs we have. So 2, we have 8 host bits. What's that going to equal? That equals 256, okay? So it's 256 IPs, okay? But that doesn't mean it's usable. We have to minus 2, okay? 1 for the name, okay, the first one, and the other one for the broadcast, okay? So we can't use 2 of them. We can't use the first one because it's like the name, the start of the domain, the start of the IP. Can't use it, okay? You can never use the first one. And we can't use the last one because that's a broadcast. That's a special reserved one, okay? So what does that mean? We have 254 usable, okay? And that's super important. So we have 254 usable IPs. So if a question ever asks you how many IPs do you have total, well, the answer is 256. How many usable? How many host addresses? Sometimes they'll also call this host, okay? Which means they can be assigned. 254 is the answer. Great. So here's the thing. How about if I need to create 2 different networks, okay? Because I have 254 usable. Great, but I don't have that many devices, okay? But what I do have, for example, and again, let's erase this, okay, is I have a doctor's office, okay? Okay, so I've got a doctor's office. Let's go here. Black, okay? So, whoops. So I've got a doctor's office. Okay, and I also have a guest network. Okay, so let's go for patients. Okay, So I still have my network of 192.168.1.0/24. But I want to create two distinct networks, okay? I want to create a doctor's network and I want to create a patient's network. Because if I create two distinct networks, then they're separate from each other. There'll be less security concerns, tons of things, okay? So it makes a lot of sense. Yes, later we can talk about VLANs and such, and VLANs is another way to separate inside of one network. But for real basic, we're just going to create two different networks from the 192.168.1.0/24, okay? And we're going to create two networks called, we can name them whatever, but we're going to create a doctor and a patient's network, okay? Now, what's important to remember is that this goes from 192.168.1.0 all the way to 192.168.1.255. Okay, so we can't use the first and we can't use the last, but that is the network range. When we subnet, we're going to take the same range and just divvy it up into smaller pieces. Okay, and the reason we do this and the reason why this is so important is because these numbers can't change. The start and the end, it's like a piece of paper. I can rip the paper into two evenly proportioned pieces of paper, but there can't be more surface area than the original paper had. Okay, so that if I rip a paper completely evenly in half, if I put them together again, it's still the same piece of paper. Okay, but I'm ripping it into equal size. And that's the other thing, is they're going to be equal size. When you get into something later called VLSM, we can actually keep ripping one piece of paper that we've ripped up already into other smaller equal size to be able to make different proportions. But for regular subnetting, we can only make same proportions. So how do I do that? Well, I'm going to look at this 24, okay? And that's 24 network bits. And to make it smaller, I'm going to borrow a host bit, okay? So right now in 24, that is 24 network bits, right? And that would mean I have 8 host bits, okay? I'm going to convert one of these host bits into a network bit, okay? So we're going to go back to our original color coding, okay? And so we got 1, 2, 3, 4, 5, 6, 7, 8. First octet, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. 17, 18, 19, 20, 21, 22, 23, 24. And then we convert it over to host bits. This is our /24, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay. So in subnetting, I'm going to convert one of these host bits. I'm going to make it a network bit. Okay. So I'm going to convert that, and we're going to make it a network bit. So we just now moved from a /24 to a /25. Okay. And the formula goes as follows. It's 2 to the borrowed bits. Okay. And so that was going to be 2, and how many bits did we borrow? How many bits did we convert from a 0 to 1? We only did 1, okay? And that will equal how many subnets we created. So 2 to the 1 power is 2 subnets, okay? And that's a big deal. So we created 2 subnets. So the next thing we need to figure out, because we're going to start writing out, so this is now going to be a /25, okay? So how do we figure out where the break is? Well, let's look at how many host bits I have left. Because remember, 2 to the number of host bits, okay, is going to tell us how many IPs we have. So 2 to the 7th, okay, because we lost one, so now we only have 7. That's going to equal 128 IPs. And again, remember, we -2 for name and broadcast, okay, which leaves us 126 usable or host, Okay? So we just created two different subnets, and we created two 128 IP length subnets. Okay? That's it. Because we converted one of those host bits, the 0, to a network bit. So we went from a 24 to a 25. How many bits did you borrow? 2. If we borrowed 2 to the 1 power, because we converted 1 bit, means 2 subnets. Okay? And then we have 7 host bits left, which is 126 usable. Okay? So let's actually, because now I'm going to teach you the magic number all rolled together, because it's kind of nice for anything that's 20, actually nice for everything, but we're going to do this here. So 24, okay, so I'm going to write this guy now, the new one, in our table. Okay, so that's a 1, 1, 2, 3, 4, 5, 6, 7, right? Does everybody agree? Because we got to write this out, because right now I know, because if I program this, that's 255, I know that's 255, and I know that's 255, but what's this last one? Well, remember, we just add what columns are up there, so that's 128. Boom, 128. Okay, so that's what a /25 is 255.255.255.128. That's a /25. Okay, fine and dandy. But now I've got to figure out where they go. For example, the doctor, okay, we're going to make this subnet 1. Okay, so we're going to make that subnet number 1, and we're going to make the patient subnet number 2. Okay, so this is still going to start at 192.168.1.0. Remember, this still has to be, it's the same piece of paper, so we still have to start and end with the same numbers. But we're going to break it, since we rip the paper in two, the start and the end for each half of the paper is going to be different. So in subnet number 1, we go from 192.168.1.0, but where does it go to? We know it's going to be 192.168.1, but what is that last number? So I'm going to show you kind of a trick that, and this is called the magic number, which is kind of nice. Okay, so for the patients, we can say 192.168.1, but again, we don't know where it starts. But I do know where it ends, 192.168.1.255. Okay, how do I know where it ends? Because again, okay, look at that. We started at 0 and it ends at 255. So we know the start and we know the end. Okay, but what's the areas in between? So the magic number goes like this. If I take like this, okay, which is going to be my host bits where I converted, the column, the last column that the 1 is in, okay, going from left to right, is what we call the magic number. Okay, and when I do this again, I think the magic number will make more sense. So it's in the column of 128. So that's going to be where the next network starts. So over here in patients, 192.168.1.128. Okay, that's subnet 2. Well, then what's the last one in the doctor? Take the first one that the next network starts at and minus 1. So 127. Okay, so doctor is 192.168.1.0 all the way to 192.168.1.127. The patient subnet's going to be 192.168.1.128 all the way to 192.168.1.255. And I just created 2 subnets from this. Now, how does the computer know it's subnetted? Because this subnet number 1 is going to have that subnet assigned, and subnet number 2 is going to have this subnet assigned. So the devices themselves didn't even know they were subnetted. They just think they're a /25 now. And because they think they're a /25, they know their network boundaries. Okay, and that's what's super cool. So ultimately, if we look at these numbers between doctors and patients, starts and ends at the same between both of them as the original /24. But then, of course, the major difference is is it's actually two different subnets. And doctors and patients, unless you do rules, by nature, they cannot communicate with each other. Okay, so all broadcasts and everything else are going to be completely separate. And this is a reason you might want to do it. Did we lose how many we can have? Yeah, we can only have 126. Okay. But that still means that the doctor can have 126 IPs usable and the patients could have 126 usable. So for a lot of scenarios, that's fine because you didn't need all 254 anyways, and we created two distinct networks. Okay, so we're going to do this again, and we're going to go for more. Okay, and we're going to do more of a scenario, as it were. So let's pause and erase this. Okay, here we go. So we're going to come up with a new scenario, and this is more of a scenario that you'll kind of hear. So there is, we're going to start with kind of our same first. So we're going to do 192.168.1.0. And for ease, we're going to start with a /24. Okay, there are more advanced scenarios, and I'll do one more advanced one afterwards, but let's start the /24 because especially a lot of your simpler certs will only do 24s and later. Okay. So 192.168.1.0/24. And automatically in our head, we should be thinking, okay, if it's /24, if we're going to start with that, this number's not going to change, this number's not going to change, and this number's not going to change. So we're really only messing with the fourth octet. And that's kind of good to know. Once we go lower than 24, like 23 and lower, well, then we're messing with the other octets. Okay, and again, I'll show you one more advance. So in this scenario, it's going to be a company. So we're going to call it the ABC company, something very original. Okay, so the ABC company wants three, okay, distinct networks. So they want one for sales. Okay, they want one for accounting, and they want one for finance. Okay, so they want three different ones. So we need to borrow subnet bits. Okay, so we started with a /24. Okay, and remember, 2 to the power of borrowed bits is going to be how many subnets we create. So if we borrow one bit and go from a 24 to a 25 like last time, well, that's only going to create 2 subnets. But if I borrow 2 bits, okay, that's going to create 4 subnets. Now, you might be like, well, wait a sec, we only need 3. Okay, but that's impossible. So you're only going to be able to do so. And imagine if I borrow a 3rd subnet bit, then that's going to go to 8. Okay, so sometimes you're going to have leftover subnets. That's just the way it is. You can have sometimes exactly the right amount, or you might have too many. We're just not going to use the 4th subnet. Okay, so we've got sales, accounting, and finance. The 4th subnet's just going to be blank. It's not going to be used. Okay, so we're going to create 4 subnets. So we're going to go from a /24 to a /26. Okay, and again, let's go ahead and figure out what that subnet's going to look like. Okay, because that's going to be important. So if we borrow 2, that means I borrowed this one and I borrowed this one. Okay, and the rest are still going to be host bits, right? Great. So we know that the subnet then is going to be 255.255.255, but our last one has changed. Okay. So we're going to take 128 plus 64, and that's going to equal to 192. So that is our new subnet. Why do we even need to write that out? Just because when we're actually programming things, we're going to have to write the subnet, and that way they know what's happening. Okay, so if we borrowed the 2 bits, okay, how many do we have left over? So now we need to figure out, so we've got 2 to the borrowed bits is 4 subnets, but how long is each network, okay? So it's going to be 2 to the host bits, okay? Well, we had 8 host bits. We borrowed 2. 32 minus 26 is going to be, we have 6 host bits left, right? So 2 to the 6th power. Now, we can figure out 2 to the 6th power, okay? And we can see how many. In fact, if we wrote the chart, then I can kind of cheat here, but 2 to the 6th power is 64. Okay, so that's 64 usable, well, 64 IPs total, right? And then we got a -2 because 1 for the name, the beginning, okay, and -1 for broadcast. There we go. So we have 62 usable or host IPs, okay? Now, here's where the magic number kind of helps a little bit, okay? So I'm gonna write here, sales, we're gonna start that. So this is gonna be subnet number 1, okay? Well, we know it's gotta start at 192.168.1.0, okay? We just have to figure out where it goes to, okay? But here's what I'm gonna do. Remember what I said, when we write out where our host and networks are, look at the last one, the last network bit, and see what column it's in. Well, hey, it's in the 64 column, okay? That's my magic number. So that's gonna be where the next network will always start, okay? So for example, I'm not gonna write the end one yet. I'm just gonna write where each one starts. So for subnet number 2, okay, I'm gonna write 192.168.1 dot, take your last one and add it to the magic number. 0 plus 64 is 64, okay? And again, I gotta see where it ends, but I'm not gonna do that yet. I'm gonna go ahead and do my third one and see where that goes. So it's gonna be 192.168.1 dot now. Look at where the last one started, okay? So it started at 64 and add the magic number to that. So 64 plus 64 is 128, okay? Now, the missing one, so this is subnet number 3. I'm gonna go ahead and write out subnet number 4, even though we're not using it, just because it'll help me fill in the rest. So subnet number 4 is gonna be, it's not used, but it's still there, it still exists. 192.168.1 dot, and now what I'm gonna do is I'm gonna add 128 plus 64. And 128 plus 64 is 192, okay? Now, the reason I wanted to write all these out is because now it makes the last piece super easy, okay? So, sales, subnet number 1, where does it end? Well, 192.168.1 dot, look at where the next one starts. Subnet number 2 starts in dot 64, so just -1. It ends on 63. Because all the numbers, you can't have missing numbers. All the numbers have to be accounted for, okay? Okay, and now let's look at the next one, accounting. So we know it starts at 64, so where's it end? 192.168.1 dot. Let's look over at subnet 3. Where does it start? 128, so -1. This one ends at 127. Okay, so where does this one end? Where's financing end? 192.168.1 dot. Let's look at subnet number 4. Even though I'm not using it, that's why I added it, because it just lets me quickly look. 192s are the next one starts, so that means this would end at 191. Okay, and subnet number 4, where does it end? Well, remember, we're doing a /24, which goes from .0 to .255, so subnet number 4 would end at 192.168.1.255. Okay, so this is a real simple way. So I just created 4 subnets because that's all I can. Okay, so I went from a 24 to 26. So I converted 2 host bits to 2 network bits by doing this. So doing that, 2 borrowed bits, 2 to the 2nd power, created 4 subnets. Yes, it's one more than we needed, but that's okay. Okay, we're just not going to use subnet number 4. And when I did that, instead of having 8 host bits, I had 6 host bits. So 2 to the 6, 2 to the host bits, 64 IPs, -2 from name and broadcast, regardless of the size. Okay, when I do this part, okay, regardless of the size, how many host bits and how many IPs I have, you're still just minusing 2. You can't use the first one and you can't use the last one. So again, on subnet number 1, I can't use .0 here. and I can't use .63. .0 is the name of the network. .63 is the broadcast. Okay. On subnet number 2, .64 I can't use. .127 I can't use either, and so forth. Okay. So what can I use in sales? .1 to .62. That's the usable IPs. That's the host IPs. That's IPs I can assign. On subnet number 2, I can use from .65 to .126. That's usable IPs. Subnet number 3, I can use from .129 to .190. Okay, that's the usable IPs. Okay, and with that, that's subnetting. Okay, if I need to create more, how about if I needed 6? Well, I can't create 6 subnets, so instead of having 6 subnets, I'd have to have 8. Okay? Just remember that I'm taking the same size piece of paper, and this time I just divided it into 4. So notice the more subnets I create, the less host addresses there are. Okay, so for this one, we went from having 256 IPs, or 254 usable, with the original /24, that once we went to /26, we're only getting 64 IPs, or 62 usable. Okay, so just like a piece of paper, the more equal pieces I fold it into and tear apart, the smaller the area of each piece of paper is going to be. Okay, now that's subnetting in a nutshell. I'm going to show kind of the magic of the magic, as it were, of magic numbers on a larger subnet. So for most of the certifications, except for the more advanced certs, they'll do 24 and have you subnet from a 24 on. But once in a while, they're going to give you a larger one. Okay, so I'm going to erase all this and let's do one advanced example with a larger one. Okay, here we go. So we're going to go to a much larger IP starting. So we're going to do something like, how big do we want to go? Let's go really big. Okay, so we're going to go to 192. And actually, you know what? Usually you won't see a 192 do this. Sometimes you will, but not usually. So let's do a 172.16.1.0/16. So in a corporate world, a lot of people are going to start with a much larger subnet. Because remember, we can start with a larger piece of paper at the beginning, but once we start subnetting, we can't go back and change that original piece of paper. I mean, you can, but it'd be a lot of work. So it's easier to, and most, again, large corporations will just start with a bigger subnet and then subnet as appropriate. Okay, so /16, this guy's big. Okay, this subnet's going to be a 255.255.0.0, right? So when we talk about this, the first one is network bits, the second one's network bits, but that's all host and that's all host. Okay, and 32 minus 16 is 16. So again, to show you how large this network is, if we go 2 to the power of 16, how many host bits we have, there is 65,536 IPs. Oh, but wait a sec, minus 2, right? For the name of the broadcast. So how many usable IPs in this particular network? 65,534, right? Because if I minus 2, that's how many usable. So this is an absolutely massive. And some people might say, well, why wouldn't you just want one this large? I mean, you don't have to worry about IPs because of things like broadcast. Remember, that last address is a broadcast, okay? And that's going to be problematic because if that last one's a broadcast, then it's going to be shooting off over a whole lot of IPs. So actually making your network too large can make it slower. That's why even at home, you probably have a /24. You might actually want to move to /25 and just make it 128 IPs. Yes, you're going to lose some of the power of IPs, but do you really have 126 devices at your house? -1 for your router, 125 devices, not on a home router. Okay, it's not going to handle it well, not unless you moved up to a prosumer or commercial router. So it actually could make your network a little faster, okay? So this one's huge. Now to kind of figure this out, like where does this go to? Well, okay, so that means we're going to go from 192. Our start here is 172.16.1.0, And where's this thing end? Well, it's not going to end until 172.16. And here's the tricky part is we have to figure out where exactly does this end, okay? So we go from .1. We're dealing with the third octet now, right? So we have 65,000. So again, we've got 65,534. So I'll show you kind of a trick on this. So we're going to go 2 to the power of 16 again. How many host bits? Okay, so 65,536. Now, if I'm dealing with the second octet, let's think about this. The first octet goes from 0 to .255, right? So there's 256 combinations. Once this goes all the way to 255, 1.0, 16.1.255, and I add one more, then this becomes a 2, the 1 becomes a 2, and then it goes back to 0. Okay? Almost think of it like if the ones place and the tens place. I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I want to add one more, add 1 to the tens place, and then the ones place resets to 0, right? Same concept here, okay? So in order to figure out where this ends, I'm going to take this large number right here and divide it by 256. That's how many times the fourth octet will turn over. Okay, so 25536 divided by 256 is 256. Okay, well, what does that mean? Well, that means I can't quite do that because I still have to minus the 1, okay, because you have the 0 to 256. But what it does mean is that this last number is that. Okay, and actually, that's not true. Excuse me. The last would not be a 0. It would be 255. Okay, so /16 starts at 172.16.1.0 and goes all the way to 172.16.255.255. Okay, because if I added one more to this, then this 255 would reset to 0, and that would go up, but we can't go to 256. That would go to 0. And then that would change to 17. Okay? In which case, then you can't do that. Hopefully that makes sense. Okay, because 172.17.0.0, which is what would happen if I added one more to this, is a different network. Okay? And I know that because look, that's a network bit that can't change. Okay? Same thing, conversely, if I were to take 172.17.0.0, okay, and I minus 1 from that, that would turn to 172.16.255.255, okay? And hopefully you can conceptualize that, and I'm just kind of writing that because sometimes that's nice to be able to understand. These are really large numbers we're dealing with, okay? Okay, so why did I do all this? Because we're going to divide up this /16, and we're going to make, let's go 4 networks. So we want 4 subnets, okay? So in order to do this, we're going to go 172.16.1.0, okay? That's a /16. And we know where this ends, and that's important because we already showed that, right? So we're going to make 1, 2, 3, 4 subnets out of this, right? So subnet number 1, subnet number 2, subnet number 3, subnet number 4. Now, even though we're dealing with huge numbers here, the process is still the same, okay? Meaning that if I want to go from a /16, I need 4 subnets, then I'm going to do 2 to the borrowed bits. Okay, well, how many do I need to make 4? I just need to borrow 2, okay? So 2 to the second power is 4 subnets. So I'm going to go from a /16 to a /18, okay? So that's big. So when I go to /18, here's where the magic number is going to be beautiful, because again, we're dealing with big numbers. I'll show you another way to do this, but the magic number is really nice here. Okay, so I'm going to write this out. So this is going to be 172.16.1.0. It has to be, right? Because we're still starting at the same point. But again, we're going to a /18. Okay, the second subnet. So in order to kind of figure out the second subnet, let's type in our new one. So what we did here is we went from a 16 and 18. Which one are we messing with? We're messing with the third octet now. We've been messing with the fourth, but now we're messing with the third octet, okay? So the third octet originally had, it had all zeros, right? So we converted two of those zeros to one. Well, how many did we borrow? We went from 16 to 18. And again, if this is still confusing, write out your stuff. So we got a /16's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the rest are host bits. 16, 17, 18, 19, 20, 21, 22, 23. Okay, 1, 2, 3, 4, 5, 6, 7, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, that's the binary equivalent of /16. We converted that one to 1, and we converted that one to 1, right? So by doing that, instead of we've been putting the fourth octet in this, we're going to go ahead and just put in the third octet, because that's the one we're messing with, okay? So we borrow 2, so that's a 1 and a 1, okay? And then the rest are zeros. Now, how many host bits do we have? Okay, let's check that out. We've got 2 to how many host bits? So how many IPs are there? That's going to be a big number, because we have 8, 9, 10, 11, 12, 13, 14. So 2 to the 14th power, okay? So this is a huge number, okay? And again, how big is that? Well, let's look. So we've got 2 to the 14th. And again, I'm just taking 32 minus 18 here, right? And let me show you that. 32 minus 18, 14, right? Or I can count the zeros out. Okay, so 2 to the power of 14. There we go. So 16,384. So 16,384 IPs. Minus 2, right? But reason I'm pointing this out is because we can deal with that number, and I'll show you another way we can deal with it if you have a calculator. But if you're doing this without a calculator, it's much harder. The magic number still applies. It just applies in the third octet now, because that's the one we're messing with. So here, again, I'm just going to go 172.16. I was at dot 1. Okay, that's where I originally was. So I'm going to add, where's our last number? Well, it's at 64. Okay, right? Look at the column. So the last one is at 64. So since it's at 64, I'm going to add 64 plus what was in the third column. So 64 plus 1 is 65. Okay? Dot 0. That's where subnet number 2 starts. Where's the next one start? 172.16. Let's add 64 plus 65 together. Okay? So that's going to be what? 129. Right? Oops, or dot there. Okay. Oh, we have our dot. Okay, so 16. Hold on. I forgot the one there. So let's go ahead and make sure that's there. So 16 dot, and again, 65 plus 64 is going to be 129.0. Okay. Okay, then we do the same thing for the next one. Okay. So it's 172.16, and we're going to take 129 plus 64. So that should be 193.0. And again, make sure that you have this right. So let's go, we had 129 plus 64, 193, okay? And if you're not sure about that, just write it out by hand. Okay, make sure you have it right. So that's where this magic number excels, because we're dealing with this huge number here. Okay, but this makes it super easy to come up with the first. Well, if I can come up with the first, that means I can easily come up with the last. So where's this network range? Well, 172.16, those are network bits. Those are not changeable. Let's look at the third. So if the last one here, if the first one of subnet 2 starts at .65.0, then I just minus 1. So what's 1 minus 172.16.65.0? That's 172.16.64.255. Okay? And I'm going to do the same again. 172.16. Well, if the next one starts at 129, then that's going to be 128.255. Okay? Because if I add 1 to that, I get the next one. Where does this one go to? 172.16. Up, the next one starts at 193, so this must be 192.255. And then this one is going to be 172.16 dot, and we know where this guy's got to end, 255.255. Okay? Now, I do want to caution, just happens to be the examples I'm using. We're like, oh, so the first network always starts on 0 and ends at 255. No. And in fact, sometimes in subsequent numbers, it doesn't start on .0. I'm just ending on very even numbers. But a lot of times they'll start and end the last, as you saw in a /24 to /26, the beginning, the name of the network and the broadcast does not have to be 0 and 255. Okay, it just happens to work out when you do the even cuts, /8, /16, /24 they do. Okay, so we now have all of our network. So subnet number 1, that is the range. Subnet number 2, that's the range. Subnet number 3, that's the range. Subnet number 4, that's the range. Okay, so the magic number was super, super helpful here. There is another way to do it. So once I figured this out, and that's why I want to show you why I think the magic number is really nice. Okay. So we here have 2 to the 14th power, right? Whoops, let's write that in. 2 to the 14th power. And we get, and let's actually try that again, 2 to the 14th power. There we go. So 16,384, okay? So this is dealing with, and we talked about this, if we look over here, that's dealing with the third octet, right? Well, how many times does it take for that first one to change the second one? 256, okay? So on this new one, that when we borrowed these bits, I can keep dividing this by 256, okay? And notice 64, okay? So 64 is where it's going to go, but we started on 1, okay? That's where it's kind of weird. If I had done a .0, it would have been nice and even, but that's not what we started with. We started with 172.16.1.0. But if I take this number and divide it by 256, 64 plus 1 is 65, okay? And I can keep doing this now that I've got the number, okay? So I can then say 64, plus 1, there you go, 65, there we go, 65, okay? Oh, so 65 plus 64, 129, plus 64, 193, okay? So you can do the one more step of dividing that, but why? When we already had the magic number. We didn't need to do that, okay? So the magic number, it still works in the third, works in the fourth, works in the second. As far as subnetting, we will never subnet the first one, okay? You can, technically you can, but we do not go lower than a /8. /8 is considered the lowest we're ever going to go, okay? Conversely, one thing that's important, /8, all the way, if we do a /30, now think about this, if we do a /30, okay? Actually, let's pause for a sec, because this is important to define. Okay, I want to erase everything and start new, because this is important. So when you talk about a /8, okay, that's huge. Okay, because a /8, when you think about it, that means you still have, that's your first, network bit. So that's going to be a network and then a host and a host and a host. Okay, so you have a /8. Well, 32 minus 8 is going to be 24. So you've got 24 4 host bits. So this is a massive, massive network. So we're not really ever going to mess with the first one. Meaning, if it's 10.x.x.x.x, so 10.x.x.x, meaning x meaning any number, that's going to be the smallest we mess with. Because otherwise, when you start changing this one, it becomes really complicated. So nobody ever starts with one smaller than /8. We're going to at least leave the first octet alone. Okay. Conversely, though, what's the smallest network I can have? So this is important too. So let's talk about a /30. Okay. Well, if you talk about a /30, then how many IPs do we have? Well, it's 2 to host bits, right? Well, 30, if those are all network bits, I only have 32 bits. So that means 2 to the second power. So that would be 4 IPs. But remember, we have to minus 2. 1 for the name and 1 for broadcast. So how many IPs does that leave us? 2 host IPs. You may be like, okay, that's a silly network. You'd only be able to assign 2 different IPs? Yes. And actually /30 is used a lot in router to router. So if I have a router and I have a router, this router is probably connected to a switch, and that's going to be connected to end devices. This router connected to switch, connected to end devices. Okay. The link combining the 2 routers, this over here is its own LAN. Okay. So this is LAN number 1. This is its own LAN. Say that's LAN number 2. But what people don't understand is the link between the 2 routers, that is also a LAN. Okay. Meaning, I mean, we can actually say it's a WAN, but without arguing semantics, it's its own network. Okay. So this is also going to be a network, which means I have to have IPs. Okay. So I often will use a /30 because I have 1 usable here for that port to assign and 1 there. And that's it. Okay. That's the only ones that I need. And in many ways, there's a security thing that's actually really good about it. So a /30 is used. Now, unfortunately, I'm not going to have any other devices. There's going to be no PC that I'm going to be able to use here because I've used both of my host or usable IPs on this interface and this interface. So nothing else is going to be used, but it's great for security and it's going to be super fast. So how about a /31? Can I use a /31? Short answer, no. Because now how many host bits do I have? Well, I have 1, which means I have 2 IPs. Okay. Well, how many usable do I have? None. Because you still have to minus 2. Okay. So 0 usable. So that's not going to work. Okay. So you're never going to see a /31 because there's nothing to assign. Okay. So there's nothing there. More so, a 32 is an impossible network because then I have 2 to the host bits. Well, I have 2 to 0. Okay, so what do I have? 2 to the 0 power, that's 1. Well, I can't minus the 2 from 1. Okay, so /32 is an unusable, an unusual CIDR notation. It's an unusable network. You can't have a /32. You could have a /31, but you can't. That's also unusable. Okay, 32 is impossible. 31 is unusable. 30 would be the lowest I would ever go. Okay, because that one actually is usable, usually between 2 routers. So I want to do this aside just to kind of see what you're going to be working with subnetting. So you're going to be from a /8 to /30. Most of your simpler subnetting challenges will be from a /24 on, so like 24 to 25 or 26 or something like that, because you're only dealing with the 4th octet. It's a little easier. But some of your more advanced certification will go from a /16 to /23, messing with that 3rd octet. But as I showed you, it's totally doable, especially if you use the magic number. Okay. Now there's one more thing called a variable length subnet. I'm just going to briefly show you what that means, but I'm not going to teach you how to do it. But it's not too hard. The hardest part is just making sure that you have no overlap. And that's the main thing about when you subnet. The numbers can't overlap. Okay. VLSM basically is saying, though, so I'm going to take my piece of paper and we're going to divide this into 4 subnets. Okay. What VLSM says is, okay, I'm going to take one of these subnets and divide it again into another 4 subnets. And I could even take that one and divide it again into, say, 2 more. Right? Now, they're going to keep getting smaller and smaller and smaller, but what it'll allow you to have is unequal subnets. I mean, within themselves are all equal, but it'd be unequal otherwise. VLSM is not on the Network Plus. It is on the CCNA, but there it is. Okay, and with that, that is a subnetting primer. So hopefully this helps as either new learning or review, and we'll look at IPv6 subnetting in a future one, but IPv6 subnetting will take all of 5 minutes for a video because IPv6 is not doing a Band-Aid solution. IPv4 is never really meant to be subnetted like we're saying. It was meant to have subnets, but not subnetted, not breaking it into smaller ones. Therefore, that's why there's all this kind of mathematical binary math, where IPv6, they just built it in. Because IPv6 new subnetting was needed, so it's extremely easy. You're literally just incrementing the 4th hextet by 1. There you go, I just taught it. But I could do another video if you're interested. And with that, hopefully this helps. Thanks.